Free body diagram part 2. Object A is on a rough surface, so free body diagram for object A is normal force exerted upward, the weight is downward, pulling force F with the angle 30 degree, there's a tension, and because of it is a rough surface, so there is also friction exerted. We need to resolve F into the X component and Y component because of it is not at the X or Y component. When we apply Newton's law of motion, sum of Fx is equal to ma. So we get that Fx minus F minus t is equal to ma. Fx is F cos theta equal to ma plus F plus t. For the y component, sum of Fy is equal to 0. So Fy plus n minus Wa is equal to 0. F sin theta is equal to Wa minus n. For object B, there is a tension and also the Wb, and the direction of object B is upward. We apply the Newton's first law of motion. Sum of Fy is equal to, we will apply for object B, the forces exerted on the object is tension and Wb. The direction of motion is upward. So when we apply Newton's second law of motion, which is at the y component, is equal to ma, we get that T minus Wb equal to ma, and T is equal to ma plus Wb. Do take note that Wb is equal to mbg. For object B, the forces exerted is Wb, T3 and T2. T3 is not at the y or x component, so we need to resolve T3 into the y and x component with the angle of theta. When we apply the Newton's law of motion at the x component, so we get T3x minus T2 is equal to 0. So T2 is actually equal to T3 sin theta. At the y component, sum of Fy is equal to 0. So T3y minus Wb is equal to 0. So Wb is equal to T3 cos theta. System with the object, we need to sketch the free body diagram separately. So for the object A, we assume as a point object, there is a tension exerted away from the object A and the weight exerted downward, and the object A is moving downward with the acceleration A. So when we apply the Newton's law, because of it is at the y component, so sum of Fy is equal to ma, and W is same direction with the acceleration, so W positive minus T is equal to ma. We can write down that the T is equal to W minus ma. For this system, which is object A on the rough inclined surface, first we need to sketch the free body diagram for object A. So this is the inclined plane and object A is a point object. The forces exerted is the normal force exerted perpendicular to the surface. The weight is Wa. There is a tension because of there is a string connected object A and object B, and friction force exerted oppose the direction of motion of the object. Now we will apply the Newton's law of motion. Sum of Fx is equal to ma because of the object moving with the acceleration A. And then do take note that for the W A, it is not the y or x component, so we need to resolve WA to the y component and x component. Okay, because of that, from the Newton's second law of motion, the forces with which same direction with A is positive. So we have T plus WAX minus F is equal to MA. So we get that T is equal to MA plus F minus WAX. For the y component, sum of forces at the y component is equal to 0. Because of that, N minus WAY is equal to 0, and N is equal to WAY is equal to WA cos theta. For object B is hanging, so there is a tension away from the object B and WB. Do take note that object B is moving downward with the acceleration A. So when we apply, we just have the y component. So Fy is equal to MA actually. So sum of Fy is equal to MA. WB is same direction with the acceleration. So WB minus T is equal to MA. We get that WB is equal to MA plus T. When we apply the Newton's second law of motion, sum of Fy is equal to MA. So WB minus T is equal to MA. Because of that, T is equal to WB minus MA. That's it for the free body diagram and application of the Newton's law. Thank you for watching and all the best.